Yep.
Able to exempt from the final.
Sorry?
When are we able to exempt from the final?
I don't know when they're going to send it out. My guess would be probably Monday of next week is when they'll send out the form, and then a few days after that, they'll send it to us. I'm just guessing. So. Alright, good morning guys. Our bells are going to be turned off again this week, and I'm assuming they're going to skip moment of silence and stuff for that too, because of AP testing. Some of the AP testing is on campus. So let's go ahead and talk about the plan for the week here. So the two papers you picked up this morning are 123. It makes up the test review. And so it's the same stuff we've been talking about, but especially the first page or two. The questions are kind of phrased in a different way to get you to think about it a little bit differently. So instead of just giving you a rational function and asking you to find any and everything about it like we did last class, you can look at questions 1 and 2. It gets you to focus just on one skill. It talks about which one of these would have a y-intercept and what is the y-intercept of the one that has it. So it forces you to think about when would there be a y-intercept and how could there not be a y-intercept. So same skill, just a different approach, trying to get you to learn those rules from a different angle. Then it goes on to do the same thing for x-intercepts and horizontal asymptotes and vertical asymptotes, etc. Eventually, with question 15 and 16, those two are like two that we did last class, but instead of asking you to find everything and then put it on a graph, it just asks you to graph it. So if you think knowing the vertical asymptotes helps, then find them. If you think the x-intercepts help, then find them. If you think it doesn't help to make up the graph, then don't find them. It's a little bit more open-ended. Kind of the same idea with page 3. Those are just multiple choice questions. So really you can just pick out one skill, try to narrow it down. If it narrows it down to one choice, then great, there's your answer. If it doesn't narrow it down to one, you might have to do a second thing. And then the back page is stuff from section 2.5 from a week or two ago. About zeros, imaginary zeros come in pairs, knowing how long division or synthetic division can reduce the degree of your polynomial to help you find other ones. So if you notice on our agenda board here, I have kind of mixed things up. This doesn't really impact our class that much, except that I did switch a couple classes around. So even though this is the test review, our test is not next class. It's not going to be on Wednesday. On Wednesday, instead, I'll ask you to work on the semester test review. So I basically switched what our original plan was with Wednesday and Friday because I felt this way, if anything, it gave you 2 more calendar days to review and be ready for this test, but at the same time still get some time to work on the semester test review. So today all you need to worry about is working through the review, the test review, and seeing if there's anything that you would like re-explained to you, and finish that up. And then the handout that we had last class had, I don't remember, there's 13 or 14 questions or something. I asked you to get through at least question 9. So when I ask you to turn that in, which is part of your homework, you need to have at least the first 9 finished. Now you are certainly encouraged and welcome to finish it up and do the extras for practice. You just don't have to do the extras for practice on homework. But if you think, I don't know, if you think slant asymptotes are your struggle, maybe you could just do slant asymptotes for the rest of the questions and not do the rest of those if you feel good with the other parts. So just a suggestion there. So again, test review today, test is on Friday. Wednesday I'm going to ask you to work on your semester test review that I gave out a couple weeks ago. So you can't just delay this until Wednesday because your test is not till Friday. You really should work through the review completely today, and then if you feel like you still need to do some extra studying, you've got a little bit extra time. So that's the plan with that. So if you guys do have any questions with the first 9 of the handout from last class, obviously I'd be happy to help. And once you have some time to try these questions on the test review, then I would be happy to go over any of those with you as well. But of course, this test review is for the last unit exam, so it should be a 50-point exam. And then the only thing left to worry about is the semester exam. Of course, the semester exam is going to have questions like these on it, so learning this and knowing this well should mean that you have that much less to study for your semester test. But we'll talk more about the semester test on Wednesday. Some people have asked about exemptions and stuff. We do allow exemptions just like we did first semester. We do require you to finish a certain amount of the semester test review. It's really just dependent on how much class time we give you. So again, I plan on giving you all Wednesday to work on it, so I would suspect you could get a good chunk of it done. I'd already asked you to do 10 questions, and we'll have one more class period, so however much class time I give you to work on that is part of the exemption process. As far as when the exemption form's coming out so that you can apply for exemptions, my guess would be that that's probably going to come out next Monday, but I have not officially heard anything about that yet. So you should be actively looking through your student announcements each day. You're really supposed to check those each day anyway, but you don't want to be slipping on that. I can tell you, I did have one senior who didn't get to exempt her finals because she didn't fill out the form, and that is part of it. If you guys look at the exemptions, if you don't remember what the requirements are for exemptions this year, I think they'll be different next year, but I do have a hard copy you're welcome to come look at or take a picture of. But the very first one says you've got to do the exemption on time, so make sure you're looking for that. Okay, I will get out of your way here for a couple minutes and let you start chipping away at this test review. And then as usual, as you guys find something, you're welcome to ask me at any time, but I will allow questions to be worked out on the board here in about 15-20 minutes once you've got a chunk of it done. So go ahead and start on that, please. Do you know where Mr. Deep's room is? He's the yearbook teacher. Okay, all right. Do you have the yearbook that you haven't picked up that you paid for? You can pick it up anytime from like 8:30 to 4:30. But I think it's already paid for, so you just need to remember to go get it. Bless you. Of course, feel free to jump around on this test review too. If there's something that you're not super comfortable with, you're going to want to ask about it anyway, so don't spend too much time on it. Just move on and get something else done that you know how to do. I know it's been a little early here, but you guys might have found a few questions I can help with. So I'm going to assume everybody's still looking at the first page, but is there anything 1 through 10 that I could go back over to help out? Okay, nothing right now? Okay. I'll check back. Okay, I'm gonna offer another round of questions here. So maybe anything from the front or back of the first page, the first 16 questions.
Maybe 5 and 6.
5 and 6. Okay, let me see if I All right, so question 5 and 6 are asking us to focus on horizontal asymptotes. So the part that we have to have memorized for horizontal asymptotes is you have to know this is the type where you compare the degree of the numerator to the degree of the denominator, and then there's one of 3 things that could happen. If the degree of the numerator is bigger, it doesn't have a horizontal asymptote. If the degree of the denominator is bigger, it's y equals 0. And if the degrees are equal, it will be leading coefficient of the numerator over leading coefficient of the denominator. So the one that does not have a horizontal asymptote would have to be 5b, because the degree of the numerator is bigger than the degree of the denominator. That just means if you go far out to the right of the graph and to the left of the graph is either going to infinity or negative infinity. But without doing some more work, we don't know which way it's headed. Okay, so that means 5a is the one that does have a horizontal asymptote. Now, I tried to make this one a little bit trickier to make sure that you were really paying attention here. The degree of the numerator is not 1. These don't have to be written in descending order. The degree is the biggest exponent. So the degree of the numerator was 3, the degree of the denominator was 3. So the equation for the horizontal asymptote will be y equals leading coefficient over leading coefficient. So you have to remember that coefficient just means the number multiplied by x, but leading coefficient is the number that's being multiplied by x with the biggest exponent. So it should leave us with 3/4. So again, these don't have to be in descending order. And if that really bothers you, you can move them around and put the biggest exponent first and then the next biggest exponent. I know you tend to see it set up that way for you, but it doesn't have to be set up that way for you. Okay, is that enough? All right, anybody else that was going to ask about 5 and 6 need something more detailed there? Okay, then do you got any others ready? 1 through 16? Yeah. 3 and 4? Sure. All right, so 3 and 4 are both about x-intercepts. And for rational functions, that is any number that makes just the numerator 0. So if one of these has an x-intercept or 2 and one of these doesn't, you should try to think about what numbers make the numerator 0 here and what numbers make the numerator 0 here. Now on the right, this is going to work out great. Undo a -9 with a +9, undo a times 7 with a divide 7. This guy has an x-intercept. As long as this doesn't also make the denominator 0, which makes it a whole, it would be an x-intercept. And I don't know what that would come out to be, but it doesn't come out to be 0. So the problem with this one, so the one that does have a y-intercept is 3b, and it is 9/7 0. When x is 9/7, y is 0. The problem with 3a, and the reason why he doesn't have an x-intercept, is if you try to find the numbers that make the numerator 0, you get plus or minus 2i. And there's nothing wrong with imaginary numbers, but imaginary numbers don't show up on a normal xy plane graph. It's not going to show up as an x-intercept. There's nowhere for you to plot 2i and negative 2i in an xy plane. So that's why 3a would not have an x-intercept, but 3b would. Nothing made the numerator 0 on 3a. Something did make the numerator 0 on 3b. right, let's go ahead and keep on going. If you've got more, anything else, 1 through 16, ready to go? Okay, I'll give you some more work time then. Okay, checking back in with you guys. Let's see if there's something else. So let's try stuff from page 1, 2, or 3. So it would be questions 1 through 20. Any of those that I can help with yet? Alright, I'll give you some more work time here. it's been a while here, so let's give you another chance. So, I know you might not be finished with it, but anything from any page 1 through 28.
16.
Number 16. Let's see if I can get this one. All right, so 16 is a rational function. So this is what we looked at last class, except last class it specifically said, find the holes, find the x-intercept, find the y-intercept, find the sine asymptote, find the horizontal asymptote, basically find everything. And this one gives you a little more freedom to kind of do what you want, but you still should probably be doing most of the same things, if not all the same things. Like I can look at this and see that he doesn't have a slant asymptote. Now of course you probably wouldn't write this down, but it does not have a slant asymptote because the degree of the numerator is not one bigger than the degree of the denominator. In fact, I see the degrees are equal, so horizontal asymptote will be y equals leading coefficient over leading coefficient, y equals -1. So that's important because that's going to help me know what the very ends of my graph approach. That's all that that tells you. It doesn't tell you about anything in the middle. There's a good chance I'll need to find some points, but that's also a little bit more tedious, so I would save that for the end. I would probably, and again this is all preference, but I would probably think about the holes, vertical asymptotes, and x-intercepts, since those are all basically the same amount of work, or same type of work. So, looks like the numerator is 0 at 2 and -1. And the denominator is 0 at 0 and 3. Again, those are quadratics, so I guess you could do quadratic formula on each one, but factoring is going to be way quicker. So, this does not have any holes, so you probably don't even want to write that down to the side, but there's no holes because there's no number that makes the numerator and denominator 0. But there are some numbers that make just the numerator 0, which are x-intercepts. There are some numbers that make just the denominator 0, so those would be vertical asymptotes. And then, again, it's really just a preference thing. Whatever else that we ask you to find in those that you think would be helpful. Now, I guess you could think about the domain, but the domain's not going to help you graph it, so that's kind of pointless. You could try y-intercept, but it doesn't have a y-intercept. Because if I plug in 0 and solve, I get -2 divided by 0, which doesn't make sense. Again, you don't have to write that they don't have these. I'm just doing it to show my thoughts here. I already did x-intercepts, I already did horizontal asymptotes, I already did vertical asymptotes. Domain's not really going to help, and it didn't have a slant asymptote, and it didn't have a hole. So I've pretty much gone through the whole list of things, so there's not anything else I could really add to this other than points. So again, points are very useful. It's just that it's a really terrible way to only be able to do these. If you don't know any of this other stuff and you're trying to figure out this graph just from points, you're going to have to do hundreds of points, like your calculator does. But I don't know. I would start off with some easy stuff. Maybe plug in 1 minus 1 minus 2 over -1 plus 3 looks to be -1. So when x is 1, y is -1. Now, I didn't do this on purpose, but I'm glad this came up because, again, I verbalized this last class, but this is usually something that's, I don't know why, something about horizontal asymptotes and sine asymptotes that's hard to swallow. But these tell you what happens at the end of the graph. If your graph has a middle section like this one does, there's a left section, a right section, and then here's a middle section. It can cross the horizontal asymptote and the slant asymptote if there's a middle. It just can't cross it at the very ends of the graph. It approaches it at the ends. It doesn't tell you anything about the middle of the graph though. So while this might seem problematic, there's nothing There's actually nothing wrong with that. There's nothing wrong with it crossing the horizontal asymptote, as long as it's not on the far right or far left of the graph. Now, I think I'm in pretty good shape, but I would probably do just maybe one more point, like maybe x equals 4. Again, it's just a preference thing. If you really want another point over here, plug it in. If you're going to plug in -8, it's going to get to be kind of tough to do that arithmetic without a calculator, but if that's the one you want to do, then that's the one you want to do. So if I plug in 4, I get 16 minus 4, which would be 12, minus 2 would be 10, over -16 plus 12, which is 10 over -4, or -5/2, -2.5. So when x is 4, y is -2.5. Now, that's actually what I was anticipating, but again, I just wanted to do one more for myself just to add some confidence to my graph. So, the shortcut from just doing a ton of points is to know how it interacts around the asymptotes. At the ends of the graph, it has to approach the horizontal asymptote. Vertical asymptotes are going to be the spikes in the graph. One side's going to go to infinity, one side's going to go to -infinity. So based on this direction, I know this one's going up. Based on this direction, I know this one's going down. And I really only had to know one of those to know the other, but it's good to see the consistency. Based on this direction, it looks like this guy is going down, which means that it must be going up on the other side, which is good news, because it needs to hit this other x-intercept that I was sure about. And even though it can cross the horizontal asymptote in the middle, he needs to only approach it on the left. Now, what I would advise you, if we have one like this, or multiple like this on the test, is if you had extra time, even if you felt pretty good about this graph, you could go in and plug in any of these other values, like maybe x equals 5. And if plugging 5 into the function gives you a number like 6, that's going to be a problem. 5, 6 doesn't seem to match up with my graph, and I would know something's wrong. But if you plug in 5 and you get an answer around -2-ish, that's what it looks like it's at, then that makes me feel even better about my graph. So again, same thing we did last time. It's just not telling you to specifically tell me what all these things are. It's giving you the freedom to just pick and choose whichever ones you think help make a graph. I think they all help make a graph. That's why I thought about all of them. Okay. Does anyone have any follow-up to number 16? Okay. What else have you found? Even from the back page, because I know some of you have made it that far. What you got? 13? Sure. Okay. 13 says we've got a rational function, and you're being told it has a slant asymptote this time, although you really need to know that on your own. The degree of the numerator is 1 bigger than the degree of the denominator. That's how you're supposed to know it has a slant asymptote without being told. And it's asking us to determine the equation, so it will be y equals of the slant asymptote, also known as oblique asymptote. Actually, I'm going to do question 14 with this as well, because I just said it, but how I know this has a oblique asymptote, slant asymptote, is that the degree of the numerator is exactly 1 bigger than the degree of the denominator. So that's how you're supposed to know that. Now, as far as finding the slant asymptote, this is the one that takes a little bit more time. So you have to memorize what the process is going to be. It's going to be long division. Now this doesn't have any x squareds, so I'm going to say 0 x squareds, but that is optional. You don't have to put that there. We need to do long division, and our slant asymptote is going to be y equals whatever the quotient is. If there's a remainder, we get to ignore it. It's just y equals whatever the quotient is. Okay, so long division, this times x squared needs to give me this. So this needs to be 5x. 5x times x squared is 5x cubed. Also multiply it by 4. 5x times 4 would be 20x. Now I put a little bit of a placeholder here. I'm not going to put 20x here just because this is x squareds. I would probably put it here. I kind of like to keep the stuff lined up. Again, it's completely optional, but it's a little easier to keep up with. Before you forget, change the signs and add. So 2x minus 20x would be minus 22x. 1 plus nothing is plus 1. Okay, and then start the algorithm over again. But there's nothing times x squared that gives me negative 2x without putting an x in the denominator. So all of this guy is the remainder, which most of the time is important in mathematics, but it's not important for this question. Slant asymptotes, oblique asymptotes are not affected by any remainder. So y equals 5x would be the slant asymptote there. And to take it one step further, just to help you see what we're trying to find here, I will graph this in my calculator real quick. Now this will definitely be a no calculator test because we don't want you to just graph it and look for this stuff. We want to see that you can analyze it without having the graph in front of you. Okay, so here's what that rational function looks like. And what we just found is there's a slant asymptote at the equation y equals 5x. So the nice thing about checking in your calculator is you can graph the slant asymptote as a completely separate line, and it should just kind of squeeze in here. So you can see the graph is approaching it. The further right you go, it's approaching it. The further left you go, again, it's okay to cross it in the middle, but at the end it's supposed to approach it. And to make it even a little bit more obvious, I'll zoom out. So in blue was the function, and in red was the equation that I got for slant asymptote. And again, this just makes it a little easier to see. It's what it approaches as x goes to infinity and what it approaches as x goes to negative infinity. So that adds a little bit of confidence to my answer. Okay. Does anybody have another one ready to go? Okay, I will ask one more time based on how much time we have here. We've got about 23 minutes of class left, so I'm going to give you about 10 to 13 minutes to try to finish up and make sure there's nothing else you want to ask about. Now again, technically on Wednesday you could study a little bit more, but I will also be assigning a handful of questions from the semester test review. So don't just kick the can down the road just because you can. You don't want to start piling it up at the end of the year. So. we're down to about 13 minutes here. So if you want to squeeze any more questions in today, we need to get to it. So anything else from this test review that you'd like me to go over with you? Okay. I will be happy to take more questions at the start of class on Wednesday. But again, our focus on Wednesday will not be on this review. After whatever we got here, 100 minutes of class, you should have worked through it at least. But if there's a couple you didn't get to or a couple you wanted to put a little more effort into before you asked, then that's fine. But just make sure you have those ready to go at the start of class on Wednesday. Another reminder that I am asking you to turn in 2 of these assignments so I can start grading those. That is 121 from a couple classes ago, and at least questions 1 through 9 on 122. Those will be due by the start of class on Wednesday. Test review, you can turn in for full points still before the test.